All right. So I think we're going to get started here this evening. This webinar is being recorded and we should be able to share it to our website as well. So thank you for joining. This is the first in a series of webinars where we're going to be talking about the XX network, and really excited to have you join us. And we're also really excited to be able to share a lot more information about the work we've been doing for quite a long time here. So this is the first in a series of 8 webinars over the course of the next month or so, and they're going to be broken down into 4 main subjects. So we'll do 2 webinars on each subject, one at this hour, 2 a.m. Greenwich Mean Time, 9 p.m. on the East Coast, and then we'll have a second one early next week, early, 12 hours separate, different time zone. The 4 main topics we're going to hit today and next week will be an overview of what is the XX network, covering, kind of going through the XX network white paper that we released yesterday. The second set of webinars will be focused on a more deep dive into the technology, especially the consensus model. The third series will be focused on governance and token economics. And then the fourth one will be kind of tying it all together, and then also making sure that we address any questions that folks have been raising here over the course of the month. So for those of you who are in the webinar right now, you should have access to both a Q&A section and also to a chat. And so we encourage you to make good use of that and ask questions. We're going to make sure we leave time to answer your questions here on this call. So before we get started, quick ground rules for the webinar this evening. The first is just to simply be respectful to everyone who's part of this conversation. We welcome probing questions, and we're excited to get that feedback, but make sure that we're respectful to each other when we're doing that. The second one, for this webinar, we're not going to be able to discuss the coin sale. And so please refrain from getting into that kind of conversation. So that includes, no investment advice, no solicitations, and nothing we say tonight should be interpreted as a solicitation or investment advice or anything like that. So those are the ground rules. With that, let's get started. On the next slide here is a quick agenda. And basically, if you have access to that XX white paper, if you've got that handy, we're going to kind of just go through each of the key sections, explaining the key concepts, explaining how they connect to each other, and excited to kind of get into that. So who are we? This next slide shares who's going to be speaking to you this evening. First, we have Will Carter. He's the COO of Praxxis, former engineer at NASA's Jet Propulsion Laboratory, really has been leading the team building the praxxis consensus model. Second, we've got Ben Wenger. He's the VP of Architecture for elixxir, has really been important in bringing the AlphaNet out for everyone to be testing, and hopefully you've got a chance to use the XX Messenger. Ben's really kind of leading the great work that our team of engineers has been doing on the elixxir side. We've also got Dr. Richard Carback here. Rick is a cryptography expert, and he's also been working closely with David Chom on election topics for really almost 15 years now. And last, we've got myself, Peter Somerville. I've been working with Praxxis here, and especially helping to build the community of nodes and developers with our work. So let's jump in here and first talk kind of at a high level about what are the vision, what are the goals of the XX network. As you can see here, David Chom, our CEO and founder, has been talking about this vision for 40 years now. That in an age where data has become so important and so pervasive, right now the balance of power is that the organizations that run centralized networks that we use to interact with one another, conduct our daily lives, organizations right now have an awful lot of control over that data. Individuals tend to have much less data. And our vision is that that's something where we think we need to, at the very least, even out that balance. And so how do you do that? On the next slide here, there's kind of three key pieces you need to empower the individuals to have control over the data in their lives, to protect their privacy. And we as a team are motivated by the fact that we don't see these out there in the wild. You need functionality, robustness, and performance. So first, let's talk about functionality. The key issue is metadata. There's a lot of platforms out there that protect end-to-end encryption, the contents of a message. But frankly, it's the metadata. It's the who, the what, the where, the when around the messages you send, the data that you send and receive that gets picked up. There was I think it's a Stanford and Cambridge study a few years ago about Facebook and how, for the average Facebook user, Facebook knows more about you and can more accurately predict your behavior than your closest friends, often your spouse, and often more than you do yourself. And that's due to metadata. And so we think it's really important to have not just protection of metadata, but really to shred that at the source for messaging, for payments, and for voting. On the question of robustness, you need to make sure that your network can be protected against the whole spectrum of attacks, whether that's something from a quantum computer, just sort of a brute force attack, something that can resist against a money attack, where someone tries to buy a controlling stake in a network. You need to be able to resist against a Sybil attack. And then you also need to be careful against voting or control attack. A lot of blockchains have voting mechanisms, and a lot of those are kind of vulnerable as we see it. And last, you need to think about performance. Two key issues here about how do you maintain the speed and the scalability that you need to really have a network that can be used by everyone, on global scale and by normal consumers. And so we're going to get into these topics and how the XX network is able to deliver these key features. And so let's get started in talking about what is the XX network.
Hi, I'm Ben, VP of Architecture at elixxir. So the real question is, what is the XX network? What does it combine? What does it do? And the XX network is a combination of two projects, elixxir and praxxis, both run by David Chong. elixxir is a metadata shredding mixed network, which is accelerated in a way which has never been seen before. And praxxis is a next generation consensus mechanism and blockchain technology, which is quantum secure and has the scalability, security, and performance properties necessary for blockchain to really proliferate. Here's a basic diagram of our network and how it functions. So we've got four main components here. We've got what we call the mixing team. This is kind of the bread and butter of what elixxir does. It's messages go in, they are mixed, they are perturbed with each other and re-encrypted, and when they come out, you cannot tell one from the other, and they're fully anonymized. Some of these are just messages, data, payloads, communications to other users of the networks. Other than maybe transactions, which are passed over to the block producer running the XX consensus protocol. This produces a block, and through the endorsers of the network, has that block vetted and is then added to the blockchain. This is the highest level view of our network, and tonight we're going to get into some more detail, and then in the next set of webinars we'll dive even further. One interesting thing here is that we've had our logo around for a while, and I think most of you have seen it. Our logo isn't just a pretty way to write two X's. It's actually core to our technology. And if you look at the center block in the mixing team, you can see this is where our logo actually comes from. it's representative of our mixing technology. So I'm going to hand over to Will Carter to talk about XX coin, the quantum secure denominated currency of the XX network.
Thanks, Ben. So yeah, obviously the XX coin is the native cryptocurrency of the XX network, and like many cryptocurrencies and other blockchains, it is used to compensate the developers and the nodes of the network, the nodes who are operating the network. It's also used by the users of the network to exchange value. And something that's maybe a little different than some other networks, it's also used to incentivize governance, and we'll talk about that a little later. But before we kind of start digging into the coin itself, there are a few things we had in mind when designing, how these coins would work. And I'd say you could divide it up into like usability, privacy, and security. From a usability standpoint, we wanted them to be able to fulfill, a variety of use cases. So we want these to be pretty dynamic, be able to do things like joint custody, escrows, smart contracts, support smart contracts, but also, besides that, also we wanted to make sure that these tokens were fungible. And we can talk maybe a little bit about that later. But also privacy. We wanted to be able to enable truly private payments where we're not just hiding the sender and the recipient, but also the amount. We'll talk about that in a little bit. And then security. We've talked about a bit about quantum security here. And you're going to hear, the term quantum secure quite a bit when you talk, when we talk about the XX network. But, this is real value that we're storing here. And because we want this to be a mainstream currency of the future, it needs to not only be safe against the current threats that a lot of other blockchains are, kind of worried about, but it also needs to be secure against future threats. And that includes quantum security, quantum computing. And, if you look at what quantum computing is capable of doing, it can break many of the cryptographic primitives that we use on a daily basis, including blockchains. Most of the wallets or the cryptocurrencies out there are secured with public key cryptography that can be broken by a sufficiently strong quantum computer. And while we don't believe that such a computer is going to be available in the next year or two, there has been quite a bit of development and investment in this space. And when it does happen, when a quantum computer can break this stuff, we're not going to know about it initially. This will be likely developed by governments or large corporations, and it's likely we won't. A lot of the value of having such a computer is that you can use it without people detecting and protecting themselves against it. So we're definitely taking this seriously. And so obviously we have decided to address the threat now. We do that with so-called hash-based signatures. And this, I won't go too deep into what a hash-based signature is in this particular webinar. But, we use a version of it called Watts Plus, and it is what is used to secure every single coin in the XX network. Next slide. So yeah, there's three different ways that we are working on and we'd like to make available to spend currency in the XX network. The first one you may have heard about in previous articles or talks, which is denominated coins. And these are very similar to the denominated currencies that you use in fiat money. I won't go too deep into the technology on any of these. We'll save that for the next webinar series. But it's sufficient to say that by using denominated currencies to break up very specific amounts, we can provide, in combination with elixxir's privacy layer, it's kind of next generation privacy to all of our payments. And we write or Ben actually, I believe, wrote a blog post about this that I recommend people go read. The next one is wallets. And by wallets, I mean, this is generally what you see in every other cryptocurrency. This is, a standard multi-use address where you can send and receive an arbitrary number or an arbitrary value of coins. Obviously, we want this for specific use cases where you might want to have a static address somewhere. You don't want to regenerate. One of the issues with denominated coins is that once you spend it, that address is gone. And obviously it's denominated, so you can't keep filling it with random payments from other people. So we wanted something where you could repeatedly receive payments and repeatedly send payments without having to renew or create a new address, a public address. We'll talk more about how that works later. The downside to that, obviously, is it lacks some of the privacy that the denominated coins offers. And then finally, we have multi-signature wallets, and we've done some unique work here that we'll talk about later in the next webinar series, where this is kind of what you might use for joint custody wallets. If you're dealing with a large wallet with a large amount of money and you want like a two-man rule where no single person can send all the money out of the wallet, this is where you might use a multi-signature wallet, or even in a smart contract. And this basically just, as I said, requires signatures from more than one individual or more than one party in order to spend the money. So that's all we're going to talk about right now for the XX coin. But now we can dig into XX consensus. And if you go to the next slide. Yeah, so we're pretty excited about XX consensus. When we were designing the XX network, we knew it needed a consensus mechanism, and the first step was to see if there was a consensus mechanism out there that could work for us. And so the first step of that is defining what your goals are. And so our goals, you've probably heard them already, but we wanted finality in seconds, and that's kind of an obvious one, I think. Finality in seconds and 10,000 transactions per second. If you've heard our vision, it's that we're trying to reach mainstream adoption with blockchain technology, because that's really how we're going to fulfill our vision of a world where people are in control of their own data. So this means like bringing it outside of the bubble of just tech enthusiasts and making it mainstream. And the only way that's going to happen is if people aren't waiting all day for their transactions to complete. So we need the speed in transaction finality, but we also need to be able to push a large number of transactions through the network. And then obviously scalability is particularly important in the decentralization space, where we want as many nodes, a diverse set of as many nodes as possible in the network. And, it's important to decentralization because we want the community to take part in the ownership and operation of the network. But this also supports the next goal, which is robustness. This is robust against attacks from within and from without. So, Sybil attacks, malicious nodes, malicious clients, an unreliable network, or even like a nation state adversary. We want it to remain robust against, a wide spectrum of threats. And obviously quantum security. We've already talked about it, but it is kind of a weak link philosophy here, where, if you have quantum secure coins and no quantum secure consensus keeping the operation of the network similarly secure, you're not actually quantum secure. So let's go to the next slide. So with these goals in mind, we kind of took a look at the current spectrum of options out there. Obviously, there are many hundreds more consensus algorithms and platforms out there. These are some of the more, recent or largely known ones. I'm not going to dig too far into this today, just for time's sake, but maybe we can dig a little bit more into this in the next webinar series. What I do want to point out here is that there are three broad categories here. If you simplify this down, one is kind of Bitcoin and Ethereum, which could be described as Nakamoto consensus, can handle a lot of nodes. It seems very decentralized. It can handle a lot of nodes, but We've also seen that, some of that decentralization might be a bit compromised by these, large scale mining farms. But regardless, we do have the downside of them being quite slow. And there is the somewhat small possibility that you could, potentially lose money through forks. The next group is broadly classified as maybe BFT consensus. This is generally leader-based, usually stake-based. And so, can fall, and it's also characterized by fast finality, no forks, and high throughputs, but it kind of fails in the number of nodes that it can support. Usually you don't see more than 100 nodes here. And so that hurts decentralization, but also you have, a concentration of wealth issue, which can also affect decentralization. And then you have DAG-based approaches. Avalanche is maybe one of the more interesting ones. And, this scales to many millions of nodes. It also has, quick latency, high throughputs, and no forking. But, if there's a large number of Byzantine nodes in the network, it can actually slow down the system quite a bit. And so what you'll notice here is that no single consensus mechanism here really solves all the goals that we're looking to solve. I don't think there's a right answer. Just looking at this graph, there's obviously trade-offs. And so, with this in mind, we go to the next slide. We settled on BFT consensus, and we did this for a number of reasons. It's a well-understood approach. It's based on decades of research. We like the fast performance, the non-forkability of it, and its ability to be robust against a large number of Byzantine actors. But obviously the scalability was something we needed to address for sure. None of the approaches had quantum security, but we knew we wanted to make a consensus mechanism quantum secure. And, it also has this, potential issue where the node membership needs to be known during consensus. So nodes can't just pop in and out of existence, come and go as they please, join the network whenever they want. And so these were the cons that we knew we had to address. And if you go to the next slide, I'd like to say that I'm excited, and I think we've actually successfully done so. And we've created a pretty awesome consensus mechanism here using these 5 key approaches. The first one is NodeCon. And NodeCon is one potential way that we could initialize this network in a quantum secure manner, but also make it difficult for any single entity or person to establish a large civil presence, especially in the initial network when it's the most vulnerable. The NodeCon is kind of characterized by this in-person meeting where individuals exchange symmetric keys in order to form quantum secure authenticated channels, and then collectively create a secure random value. And we'll talk about that in the next webinar series. We'll talk about all these in detail in the next webinar series. So I'll kind of just breeze through these. But that random value that's created at NodeCon is extended and used throughout the rest of the lifetime of the network. And it seeds committed randomness, which is our next approach, which is it's a mechanism to generate unmanipulatable global randomness every block. And we do this by chaining a secret but committed value that each block producer reveals every time they're chosen to be the block producer. And that random is chained to all the previous reveals, leading back to the random generated at NodeCon. And by doing this, we create a relatively unpredictable random. It can't be predicted more, probabilistically more than a few blocks ahead of time, and it's unmanipulatable. That random is used to not only schedule block producers, but also to schedule our next approach, which is endorser sampling. And endorser sampling is one of our key, if not the key approach to the network, because it allows us to reach our scalability requirements. And what we've done here is using that committed randomness, we select a subset of the network. And this subset is the only portion of the network that needs to receive the actual signed transactions, and then verify those transactions, the signatures on those transactions, make sure there's enough money in the wallets or the coins, and then endorse the transactions in the block. And then the rest of the network just needs to receive a very compact, basically kind of a ledger saying like, here are the transactions without the signatures. If you see an endorsement from this subset of the network, then you know everything's good to go. All those transactions were valid, and you can go ahead and finalize this block. So endorser sampling is kind of a key approach we have here. But unfortunately, in every consensus mechanism, sometimes things go wrong. This is a decentralized network, and there are Byzantine actors and unreliable nodes. So eventually you will run into a situation where consensus might halt or fail, and it's important to have efficient fallbacks. And we've kind of developed a bistable approach to this where we have two key fallback mechanisms we'll talk about in the next webinar series, but they allow us to recover from either a failed BP or a failed endorser sample. And we do that in a very efficient manner. And then finally, in the age of mobile computing, everyone's got a smartphone. Everyone, spends an increasing amount of time on their smartphone, both doing business and pleasure. And so we wanted to make sure that these smartphones were capable of receiving and verifying that the transactions that they're sending to the network were completed and have reached finality. And being that we use quantum secure cryptography, which is notably, data intensive, these proofs could be quite long, especially if you need a signature or a proof from every node in the network. And so we've kind of created this novel compact endorsement scheme, which gives us a very compact quantum secure proof of finality that even your mobile devices or even other nodes in the network can use to know that consensus was reached, finality has been reached. And so if you go to the next slide, using these 5 key approaches, we think we've kind of bridged the gap here and settled at a point where we have a consensus mechanism that can really bring us to a mainstream worldwide consumer use case. So we've reached sublinear finality versus Byzantine actors. We can scale to thousands of nodes, complete finality in just a matter of seconds, and handle many thousands of transactions a second while being quantum secure and preventing forks. That's about all we got for this one, and we'll talk more in the next series.
Great. Thanks, Will. This is Peter again here. And so we've mentioned already a few times the many important roles that nodes play in the XX network. And just to kind of line those out, 2 key questions about nodes. What are they and what do they do, right? So first, what are nodes? Nodes are computer servers that are run by a global decentralized network of node operators. We've already had a pretty public process for selecting nodes for the beta net. For the main net, the XX nodes are going to be chosen through the governance process. We're going to talk a little bit about governance further down here. They're, again, running computer servers, investing their time, investing a certain amount of money in running these server computers. And so we need to make that worth their while by incentivizing them in XX coins that can take the form of either in both a block reward or an inflationary reward. See down below in our token economics discussion. And the initial set of nodes are going to participate in NodeCon, that kind of network initialization process that Will described up above. Key to our goal with these nodes is that we don't want to see the network just concentrated into a couple of data centers. We want to see whether it's a physical server, whether it's a virtual server, to have nodes be something that someone with a moderate amount of expertise, a moderate amount of resources can run. And so we're looking forward to working with our BetaNet nodes when we get to the BetaNet to really bring that in. And so what do these nodes do on the XX network is the other main question. And I think it's important to understand there's not going to be one set of elixxir nodes over here and a different separate set of praxxis nodes. Rather, every node is going to be doing mixed network. There'll be members of teams running CMIX, processing batches of messages, and they'll also be running the XX consensus, taking turns as a block producer, taking turns as endorsers on blocks. And so, we'll get further into detail again, especially this next series of webinars, we'll have more of a deep dive into the technology, but we're excited to have, we expect thousands of nodes for the mainnet, and, excited to have their talents brought together for the XX network. So next, we're going to talk about communication, and I'm going to hand the microphone over to Ben. Who should unmute himself?
I apologize. Hi. The XX communication layer, which is developed by elixxir, is one of the core, unique components of the XX network. And we'll cover the basics of mixed networks first, and then get a little bit into what's so special about CMIX, the protocol that we are using. So our CEO and founder, David Chom, invented mixed networks in 1979, and from his initial work was the proliferation of most privacy and anonymity systems. So mixed networks, his first description, is still one of the most powerful and private mechanisms for these networks. The essential idea is that, as you can see in the diagram, messages come in and they go from node to node and are reordered. And during that reordering process, they're either decrypted or re-encrypted so that no one can correlate input to output. And because successive node after successive node does this, every single node in the set would have to reveal the ordering change that they did to correlate input to output. The problem with these is that because you're re-encrypting every single message before you can send any that, before you can propagate, you end up having to wait for that entire encryption time, which is very costly. And the initial proposal for these using public key operations were too slow to be used in most environments. So in 2016, David published his paper on CMIX. And the breakthrough of this is that he figured out a mechanism to pre-compute most of these public key operations. So they're still occurring, the network still has to do that math, but they occur before a message is received. And as a result, the users who are using the network don't have to experience the latency associated with those operations. And this allows you to have very short message delivery times, just numbered in seconds, and to do so across wide batch sizes. So thousands to tens of thousands to possibly hundreds of thousands of messages simultaneously, which provides superior privacy properties to what is currently available. Now, when we look at messages related to there's two other mechanisms that can be used for metadata analysis. So one is packet length, which is that if packet lengths vary, there's only one packet length of a certain size in, another one out, you can correlate those with the same message. And the second is timing, which is that if timing is unique enough, the fact that things are mixed or jumbled together or obfuscated can be bypassed just based off timing information. So this is solved within CMIX, one, by the uniform packet size, and two, because we're processing entire blocks of messages together. So all of their timings are the same. It's also important to note that elixxir's implementation of CMIX integrates industry standard end-to-end encryption, which ensures that even if the network itself is broken, the privacy is violated, the contents of a message are still only readable by the sender and the receiver. In implementation, it's our goal to get this privacy technology in the hand of as many people as possible. As a result, our goal is to allow for free utilization of this network for the which will meet the needs of the average user. So what will happen is that users have to have an account on the network. It's a core part of how the cryptographic protocol works. And you can do this either by KYCing, which will initially occur through the token sale process, or simply by burning a small number of XX coins. And this will regularly allocate free messages to use, which will be enough for average users, but insufficient for users of dApps, smart contracts, or other businesses who will purchase additional bandwidth XX coins. It's important to note that payments actually, as we'll discuss on the next slide, operate in a somewhat different manner than normal messages through the network. And as a result, end up incurring paid messaging fees, although paid messaging fees are predicted to be quite low and more than commensurate with other payment platforms. So I want to talk a little bit how this can be used along with the denominated coins that Will spoke about to do private payments. So on the input to the network, messages are encrypted for the network itself. So while it shows here just messages or coins, the inputs can't see what's what, only who it comes from. And as it is mixed through the network, a final layer of encryption is removed, which reveals the internal payload, which could be a payment destined for the network, or it could be messages destined for delivery. And the way this works is that each payments are split into denominated coins, and each denominated interaction is submitted separately. So this disassociates the numbers of coins in the input and makes it so that the sources of coins can't be seen as well, hiding both the sender and recipient of the payments as well as the amount of the payment. So now I'll hand off to Dr. Rick Carback to talk about our governance.
Thank you, Ben. This is him. And I think the two important aspects of our governance that are most interesting is first, that our system is private. So there's a private secret ballot associated with it. The votes aren't public. And then secondly, we're really designing the system around driving turnout. And that's represented in the random sample voting system we're using. And there's a link at the bottom if you want to read about it in detail. But I'll give you the high-level overview of the pieces of it that matter the most to us. So the first one is it randomly polls a subset of the voting population. What that means is you can spend more resources on each individual voter, and you can potentially pay them to vote, and the vote is more meaningful. And because fewer voters cast a vote on a given topic, you can also have more elections more frequently without getting your voters sort of disincentivized from participating. Separately, a lot of this technology is based on these cryptographic voting systems. We've run them in Tacoma Park in 2009 and 2011. We ran them for, it was in Europe, I can't remember, maybe the Council of Europe, as a technology demo that was a binding selection for them. And we have gotten very good about running these elections. And this technology is based on a system where we use an auditing technique where we post information to the internet before the election. Then we audit that information to make sure it was posted correctly. We allow voters to vote. Then we do more auditing. And then we have a cryptographic proof that says these votes were recorded as cast, then they were correctly counted. So we have high confidence that the election results were properly, the election was properly conducted and the results are correct. And we believe that these two features together, the high security with the random sampling, sort of solve this key turnout issue, especially that we see in a lot of other cryptographic systems, but just in general, with elections, especially on mundane, hard technical projects, topics, you tend to have people just kind of tune out or not spend the effort to get into the voting. Can we go to the next slide? And then the other aspect of the system that we think we have a very good solution for is the vote selling problem. And you see this a lot in proof of stake systems where someone with a lot of resources can convince someone else to sort of vote the way that they want. And resources can be, actual tokens in the system, but more importantly, maybe personal sway or other resources, or maybe some sort of geographic location, or some sort of bribery that could happen. And the way that we cut down on that is this use of decoy ballots, where you can apply for and receive a ballot that, for all intents and purposes, when you're doing the voting action, looks like a legitimate vote, but you're given evidence that you can prove that it is a decoy later. And what that allows people to do is it allows them to convince anyone potentially that they voted, but because of the presence of these decoy ballots, they don't know if that vote was a real ballot or not. And our belief is that if we can put enough of these out into the world, that it will make it very difficult to actually buy votes. And the effect of this is, maybe this isn't good enough for a real in the world election, but in a highly decentralized system where the voters are all over the world, and you don't know them personally because they're local to your geographic region. You can't go and find them and sort of see the data come in, force them to use that data to vote. It becomes very expensive to do any kind of voter coercion or vote selling. Next slide. And finally, this is sort of the less interesting part of the section of the paper, but there's sort of these different roles of governance, right? I don't know. I think we have a very good breakdown in the paper of what each of these different roles mean. But when you're doing certain actions like adding nodes to the network or removing the nodes, you've got this interplay between different types of users. I think it's extremely useful and is going to be helpful in terms of making sure the network is incentivized and the voters in the network are incentivized to do the right things. And that's all I have.
So another important part of the network is the token economics, how the network generates revenue, how it grows. So the basic answer to that is a block reward. Nodes who do their operations receive payment as a result. And there's two parts of block reward in our network. One is fees for utilization, so fees for paid messages, among other things, and inflation. So the network is designed to have a small amount of inflation, generally 0.5 to 0.8% per year. Although if governance decides, it may have up to 2% during the initial bootstrapping, just to cover some initial costs in case there are issues. It's important to note that a small portion of block reward goes to governance in order to fund those paid votes, and a small portion to the foundation in order to cover development costs. Now, along with the block reward, we also have the initial token distribution, which is currently on the site. There's not much for me to say here. Most information is on the site, but I'll talk about it. So 70% is intended to be through sales and other dispositions, intended for the community, 25% for the team, and 5% we'll call community, which is foundation and other things for incentivizing the development of the network. And then last, we want to talk a little bit about the economics of communications. So the XX network's communication layer is unique in the decentralized space in that it isn't a blockchain. A mixed network doesn't have what's called the double spend problem, which means that you don't need to have a complete agreement over the nodes to process messages. Message is a message. You just deliver it. And this means that the complexity of delivering messages doesn't increase as the network grows. In fact, as the network grows, the number of parallel paths you can have to deliver messages increases. And therefore, the throughput of the network, the number of messages it can deliver at a given time, increases. And this creates a unique economic loop where as the network is utilized more, it gains more income. It's able to use this to onboard more nodes through governance. this allows it to increase network capacity, which in turn incentivizes the usage of more throughput. And this is a virtuous cycle, and it's we're really excited to see how this can drive the XX network. And then Will, do you want to talk a little bit about the milestones, the next steps?
Or hey Ben, this is Peter. I can cover this here, and this is our last slide before we're going to go over to some questions from folks in the audience. And so, if you guys have questions, please share that either in the chat or the Q&A section, which you can see at the bottom of your screen. So just to give you a where are we now, there's kind of 4 phases across the top of this progress bar. We had an internal test net. Right now we have a public alpha net that's in operation. Looking forward, we're going to have a beta net and a main net. And so as we go forward in time with these networks, we're going from, the initial test net was 3 computers that we own. The alpha net is, I think it's currently 8 professional node operators who we've directly contracted with, but they're outside of our 4 walls, so to speak. The beta net, we've chosen 600 node operators with the help of a lot of public input into that selection process. For the main net, it's going to be run on a network of, a decentralized network of thousands of nodes chosen through the governance process. And so from, increasing complexity as we go along, increasing scale, increasing decentralization. And again, you can see from just 15 months ago when we first announced elixxir and demonstrated the testnet, choosing the beta net nodes, releasing the first smartphone app, announcing a software developer kit, the Arrow SDK, to announcing praxxis just 4 months ago, launching that AlphaNet, launching the Messenger app, and moving forward here in early 2020, we expect to release the BetaNet, and then in late next year, we should release the mainnet. And just because that's on the right side of the screen doesn't mean that's the end of history here. We've got a lot more ongoing development that'll happen after the launch of that mainnet. But this hopefully gives you a little bit of context for, where are we? We're in that AlphaNet stage, and just really excited to be sharing this information with you. So with all that said, the next slide is inviting you guys to submit questions. And so I'm going to take a look here in the chat box. I know we've just offered a lot of information to you all, so it's a lot to digest, but we're excited to answer your questions.
So I apologize, I butchered your name, Leonid. So you want to know what information we have out there for people with different levels of knowledge. So we have released a few different documents in the past few days. The XX network white paper is designed to be relatively accessible. We also have some relatively accessible blog posts on the elixxir side, on our technology, on our website, and a architectural brief which discusses the scaling methodologies, which is also relatively high level. The one level lower, if you want something a little more complex, is there's the praxxis XX consensus paper. No, praxxis technical paper, that's the correct name, which is on the praxxis website as well, which goes into some fairly deep detail on how praxxis consensus works. And there is the CMIX academic paper, which is available, which is quite detailed on how CMIX functions. Across those, that's a fair amount of information. We also have a Discord, which we as a group are which many of the technical individuals operate and happily answer questions, which I believe I see some people in this chat who regularly participate in our Discord. So we'd happy to see you there, and I'm personally there as well as other members of our technical team. And does anyone else have anything they want to add?
Hey, Ben, this is Peter. I would just add to that by saying, you know, one dimension of our vision here is that if we make this so complicated that only 5 people in the world understand our network, then that's not a very decentralized system, right? And so our goal through doing things like all of these webinars, our blog posts, these papers that we're releasing, is that we want as much of our user base as possible to really understand and be well informed about what we're doing. And so that's our motivation here, is that to make sure that we have well-informed and active participants.
I would add to that, you know, the research papers are found on the website, but if you go and look at Google Scholar for David Chaum or myself, that's a good resource to find them. Chaum.com has a lot of the research papers. And my website, carback.us/Rick, has a lot of the research papers available in it as PDFs, free PDFs.
Will, why don't you answer this question about randomness?
Yeah, so this is a question by Byron Kingma. And he asks, you know, this is in reference to the committed randomness. He asks, should it be kept private? What could an adversary do if they compromised everyone's secret committed randomness? And this is a good question, but the answer is if a adversary was capable of compromising everyone's secret committed randomness, then they would be capable of compromising every node and could therefore compromise any decentralized network. You know, part of the definition or part of defining the adversarial models that, you know, you use to describe these decentralized systems is setting a maximum percentage of the network that you allow to be compromised. And in our particular network, we set that at 33%, or roughly 1/3 of the nodes. And so, yeah, if they were able to actually compromise everyone's secret committed randomness, they could, of course, compromise much more than just the random value of the network. So, but we have designed it such that if they were able to compromise, say, 33% of the committed randomness in the network, then probabilistically they would not be able to predict more than a handful of rounds in advance. I don't know if anyone else wants to chime in, or I don't know if I did a good enough job answering that, or if there's any further questions there.
Let's find a little bit. You can think a little bit like committed randomness as working the same way as a public and private key. Breaking the committed randomness of all of the participants in the network would be a little bit like breaking the private keys of every member of the network.
All right. Next, I've got a question from Keith here asking, have the BetaNet node specifications changed, and are they likely to change? So we first published sort of draft specifications for the BetaNet nodes, I think, in January. And so where we're at right now, you know, we're publishing these white papers and other documents, and, you know, continuing to monitor the AlphaNet. We've got now, I think, over 1,000 users on the XX Messenger, and, you know, we're going to continue to scale it up. So if anyone's still on the waiting list, you know, you're making your way to the top, testing that out. Anyway, very early next year, we're going to announce, here's the official timeline for revving up for the BetaNet. And then when we release that, that's going to have things like, here's all the dates and deadlines for the nodes on when they need to do things, and then also a finalized set of their specifications. I think those final specs are going to be very similar to what we published back in January. You know, ideally they can be, you know, lower requirements than what we said, but I think they're going to end up being very similar. Ben, I don't know if you have anything to add to that.
Yeah, we've no reason to believe that they're going to be significantly different. The one place where they may change is in storage requirements, but that is likely to be something, if it does occur, which will be a requirement for mainnet, not betanet. That being said, we're in the final processes of re-reviewing that, and we'll have a more concrete answer very soon.
Yeah. The one other kind of interesting thing about these betanet node specifications is that we asked for a pretty high-powered GPU, graphics processing unit. That's different from the AlphaNet nodes where they have, pretty hardcore CPUs. But, it nets out to the betanet computers costing about a third as much as the AlphaNet computers. And so that's, an example of us trying to make this, really on the ground as decentralized of a system as we can.
If I remember correctly, they're currently running with 18-core, 36-thread machines. So we're very excited that we're going to be able to reduce that significantly.
Yeah. All right, there's another question here from Rado asking, will the betanet and mainnet run on the same XX network and blockchain, or will they be distinct? That maybe Ben or Will would be the best to answer that question.
Obviously, we would like as much to carry over between them as possible. We certainly hope to have nodes carry over. Given that there is likely to be some discontinuity, although we don't have details at this time. I don't know if Will can give a better answer. I guess
sorry,
not.
I think I could not get my microphone unmuted. But no, I actually don't think I can say too much about this at this particular stage, other than to say that it would be highly desirable if, as many betanet participants as possible could move over to the mainnet.
Great, thanks, Rado.
Gregory asked, how easy will it be for an organization to create its own coin compared to other platforms? Right now, in the material we've released, we've not discussed smart contract or DApp, with native smart contract DApp capability. Obviously, we're aware of this and have our own interesting thoughts and plans that we hope to release more information on soon, although I can't make a commitment. And as you mentioned, at Works, we can't see much more than that, although I believe that once we're able to discuss what we're thinking of, people will be pleasantly surprised.
All right, we've got James asking us, will more information be published? Are there more papers that you're planning to release?
Yes.
We can talk. I guess we can talk about one, which is farther in the pipeline, which is that we hope to release before the token economics and governance webinars a more detailed document on token economics, which covers more on the loops and a few other components that we discussed today. Obviously, timings of these things don't always work out as planned, but that is our goal.
And obviously all the documentation that has been published will grow over time as it's developed, as we get input from the community. And then hopefully, I believe, soon we should be able to open source some code at some point in the future.
Will, we've got another question from Byron here about consensus. Are you able to see that?
I do see it. So Byron's now asking if an adversary knows the sequence of BPs and endorsers can bring honest nodes offline. Can they produce invalid blocks beyond the very low probability that the compromised nodes coincide in a particular block? I think not, just honing my understanding. And you thought correctly, they're outside of the, as you've recognized, very low probability that the insignificant probability that an adversary can get enough compromised nodes selected in a randomly selected subset of the network, the endorser sample. There is no other way that they can create an invalid block. And so I would say that your understanding was correct. Knowing the sequence of VPs and endorsers and being able to bring honest nodes offline is not enough to generate bad blocks. It is enough to disrupt the network, obviously, but one thing we've tried to do in designing the network is ensure safety in the presence of an unreliable network, which you could kind of consider this.
Hey, Ben, I think you might need to unmute your microphone again.
You are correct. I was muted. I apologize. Hi, Mark. That's a very good question and a really good point. We don't currently have a paper on the mechanism for our performance test, and that is a really good target for another release that we can do to better inform the community. I can give you a little bit of details on how we've done these. So if you go to URL, I'll type in the chat. Actually, let me first let's bring it up. Status.prod.cmix.rip. Let's hope the system is online. And it is. So this is a live, the live AlphaNet. So the way that the network works is that it's working with 1,000 batch size blocks for the mixing, and if the block isn't complete, it fills it with junk messages, which the network still processes with its full capabilities. So this is fundamentally a performance test. So you can see right now that the network is dealing with 173 transactions per second or messages per second. We're pushing an update relatively soon, which should bump this into a few thousand, which is something called pipelining. And actually, I've got a blog post where we went into details on how that works. But this is just a single team. So as I said before, unlike other blockchain of decentralized platforms, the mixed network is not a blockchain, and as you add more nodes, it gets faster. So this is the minimum speed. So the projected betanet TPS is a mathematical projection on how, based on the number of nodes we expect to be the minimum of the betanet, which is, I believe, 150, the performance that should achieve. And it increases as you add more nodes. What we're going to be working on in the future is going to be the question is absolutely correct, which is that we should provide more documentation on this, and I think we'll work on that. But fundamentally, this is a live, always running test, and this has been live with minor interruptions for over 2 months with consistent results.
Great. And we've got a question from Olivier asking about how do we make sure there's enough nodes to run the network, I guess both for the betanet and also for the mainnet. And so for the betanet, you know, when we announced our selections for the betanet, you know, of those 600 nodes, they're divided into kind of 3 teams, and every one of those betanet nodes is going to play an important role over the course of running the betanet, which, you know, probably in the ballpark of we'll have that running for about 6 months. But we divided it into a blue team, a white team, and a teal team. And our vision is that the blue team is going to be up and running on the very first day of the betanet, and we'll kind of layer in the other folks as we continue to test the betanet. There's probably going to be some amount of attrition between when folks submitted their applications to be a node and when we launched this beta net. And so that's why, we were kind of expecting maybe a couple hundred applications and hopefully 100 decent ones. And we were just blown away. We got, I think, 870 applications from more than 80 countries, the vast majority of them very high quality applications. And so what we're anticipating is that if there's members of that blue team that are not ready to go on day one, we can pull in white team nodes, teal team nodes, bring that up. Within the mainnet, how do we make sure we have enough nodes to make that work? That's going to be through the governance process that those nodes are chosen. But and again, we're going to get into more detail on governance 2 weeks from now. But one possibility is that you could increase the incentive for nodes, make it more financially attractive for them to take part in the mainnet. And so, Ben, I'm not sure if you have anything to add to that, but that's at least kind of my thought process on that.
I do. So as you can see, this is the network running with 5 nodes, and there's 3 backups in this case. The network functions with a small number of nodes, so we'll be able to run it. But there's a good question. If you don't have enough nodes, you don't meet decentralization goals. So we'll have to find ways to increase the number of nodes in the network if we don't meet acceptable minimums. Hey, Mark. In this diagram, a transaction refers to any chunk of data passed through the mixing in the network. So right now, it's just data that's delivered. Eventually, it'll be payments or anything else that the network processes. Hey, and I apologize if I butcher your name, Giordano. I'm sure I did. For the technology and language used to build the application, it's primarily written in Go. There's a little bit of management code written in Python. The stack for the cryptography primarily uses the standard Go big-int libraries, and which are generally considered to be quite secure, although they do have some issues. And for communications, we use Go gRPC. And there are a few other, we use Terraform for our deployment software. I'm trying to think what else. That's the bulk of it. We're writing stuff for GPUs for the beta net currently, and that's using
C++.
C++, yeah. And that covers most of it.
And then obviously what we're looking at is a Node.js application.
Yes, this is Node.js.
Yeah. And Ben, an implied question is, are folks outside of our team going to get a chance to look at any of that code?
Yes, I don't know the exact timeline for that. Certainly by beta net launch, before we expect any node to run it, code will be open sourced. I don't know a date when we'll do it sooner, but we hope to be able to release at least partial open sourcing soon.
Great. So Bob is asking, what about XX Messenger rollout? So we now have more than 5,000 folks who created accounts on the XX Collective app, which gives them a position on the list to get access to the XX Messenger. I believe we've got a little bit over 1,000 folks who've been processed in and given a code to join the XX Messenger. Our goal is to continue to grow that consonant with testing this AlphaNet, discovering bugs, solving them. There's both kind of back-end issues there with making sure the network, the AlphaNet is robust, as well as front-end issues around keeping an iPhone, iOS app, and an Android app running pretty well. But so long as we're able to stay on top of that, we're continuing to flow more users into the network. And Ben may be able to talk a little bit more on the timing on that, but I expect, just about everyone who's in line right now should be in there before the end of the year. That's my sense, Ben, but you're more in the day-to-day fight on grabbing those bugs.
I'm not actually sure where we are on the timing. I apologize. Right now, so right now we have about 5,400 users on the XX Collective, and I can quickly ask where we are in that process and get back to you probably before the end of this webinar.
Right. Thank you.
So about choices that are written in stone by technical constraints. This is a really interesting question. There are very few that are written in stone. There are some where you want to do in certain ways. So for example, the AlphaNet currently has 5 nodes in a team. If you only have one, the fewer nodes you have in a team, the less privacy you have, and we'd like to actually bump that up to maybe 8 or 10 in the beta net. We'll see how things pan out. But there are certain things that are hard to change. So for example, the hash function you're using, certain cryptographic primitives, but nothing comes to mind as extremely unchangeable or impossible off the top of my head right now. I might be able to return to this later. It's not a question I'd thought much about.
All right. Are there any other questions? I'll leave that. I'll give you a little bit more if attendees have any other questions. So this is the first of a series of 8 webinars that we're going to be hosting over the course of the next month. And it's going to be 4 sets of 2 webinars, one at this time of day, and one, so the second one is going to be early next week, I think Monday or Tuesday, but 12 hours different, hoping to catch folks in as many time zones as we can. And so we'll do one more of these kind of overview webinars, 2 that are going to have more of a deep dive into the technical information, especially around consensus, a set of 2 webinars on governance and token economics, and then wrap up with 2 final ones tying it all together. So kind of grabbing any questions that we haven't addressed. And, we're going to continue to monitor, especially our Discord and our Telegram groups. There's a lively conversation going on in there already, and we invite you to join us on those channels as well. All right, I'm seeing no further questions for now. And so again, please contact us on social media, especially the Telegram and Discord channels. If you have any questions we missed, and we'll catch them in the next webinar. Thank you so much for joining us this evening. It's really exciting for us to be sharing these details, all this information. We've kind of had our lips buttoned up for a long time, and so it's exciting to get to share this with you guys and with the world. So thank you, and looking forward to talking again soon.
Okay, have a great day, everyone.
Thank you, guys.
Thank you very much for attending.